Okay, this is quiz 4, question 1. Now we are starting to deal with annuities. In this case, they're asking what type of annuity. So let's start by looking at what is an annuity. So let us go in here. An annuity is a series of equal payments at regular intervals. Okay, so before we didn't use payments, remember, in our calculations because we were doing compound interest. All right, so let's look at the question. So that's the definition. An annuity is a series of equal payments at regular intervals. All right, so this question I copied into Word, which is right here. And Salvador will make deposits of $8,280 at the end. Okay, and that will become important to us as we look at it. All right. At the end of every 6 months. So these deposits are actually payments. So this would be the PY is equal to end of every 6 months, so it's twice per year. Okay, so PY would be 2, and into an account earning 5.31% compounded quarterly. Now this is also important here. It's compounded quarterly, so that tells us about the compounding, which is, we know that from the compound interest, that is CY, so it's quarterly, so that would be 4. Okay, so here we are, we have PY and we have CY. So those are the important quantities. All right, so let me list them here. So they are END, end, so it's the end of the period. And then we have PY is equal to 2. And then we have CY is equal to 4. So what do we notice? That we notice that PY is not equal to CY. All right, so that is an important bit of information. We will see how we determine what kind of annuity it is. All right, so let's come over here. This presents a general picture of annuities. Okay, they're periodic payments, and those payments can be made at different intervals. Of course, you could have annually, semi-annually, quarterly, monthly. But it could be made at the end of a payment period, or it could be made at the beginning. All right, so that determines where they go. So if it's at the end, now PY and CY can be equal. Okay, payment is not 0, there are payments, and PY can be not equal to CY. Okay, so here is the section we're dealing with. So in this case, remember, we saw that PY is not equal to CY, and it's at the end. Okay, at the end of every 6 months. So what that brings us to, it's this one right here, where PY is not equal to CY. So in that case, we end up with this one right here. PY is not equal to CY, so okay, let's try that again. Okay, so here we are. So we'll have this one right here. Okay, so that would be the answer. So it's an ordinary general annuity. Okay, so that would be the answer in this case. All right, so let's come out of here and we will go back to our original question, which was right here. So this would be classified as an ordinary general annuity. Now, I like to just use the acronyms OGA, Ordinary General Annuity. So let's get back to the question. So we will select which one? We'll select Ordinary General Annuity and we submit, and the answer hopefully is correct. All right, so that is question number 1. Okay, next one. Question number 2. I've copied this also. So let's go to our let's go to the Word document, and here we are. We have question number 2. Okay, deposits are made at the end, so there we have end again. All right, of every 6 months. So this tells us that what? They're the deposits, so PY is equal to 2. All right, so that's PY is equal to 2. And there we are. Into an account earning 5.58% compounded semi-annually. So compounded semi-annually, that means that CY is equal to 2. Okay, so CY is also equal to 2. Okay, so let's do a bit of analysis here, and we know that is part of it. PY is equal to 2 and CY is equal to 2. So what does this mean? Well, it means that PY is equal to CY. All right, so PY is equal to CY. Okay, so there we are. Now, if we go back to over here, let's go to the slide view and we'll probably see things a bit better. So PY is equal to CY. The payment is made at the end. So if we go to our marker, I guess we have to get a little bit of, let's see if it works. CY is equal to CY. Okay, so it seems as though we can get the marker. All right, so let's get to here, and maybe our highlighter will work, and here we are. So this would be the one that is correct. Okay, so it's an ordinary simple annuity. Let's get it larger. Maybe we can do better. Okay, there we are. So it's an ordinary simple annuity because the payments are made at the end of the payment period and the PY is also equal to CY, right? So that would be an ordinary simple annuity. Okay, so we'll go back here and this would be ordinary simple annuity. So there we are, question number 2, and we submit, and the answer is correct. All right, so next question. Okay, so that is 1 and 2. I don't think we need that anymore. Okay, we can bring up the calculator now. Okay, now quiz 4, question 3. Let's look at it in the Word document. So let's go down and we are here. Okay, deposit 200 at the end of each quarter into an account earning 2.9% interest compounded quarterly. How much will you have in the account in 15 years? All right, so the deposit is $200. Okay, so let's go. We could actually do it right here. The deposit is $200, so that is a payment. All right, so payment $200. So we put it in negative because it is leaving our possession. All right, at the end of each quarter, so that is for the PY. All right, which would be 4. Quarter means that would be 4. Okay, earning interest at 2.9%, so that is the interest rate, 2.9, and it's compounded quarterly. So compounded means CY is equal to 4. All right, so what do we have to do? Well, the present value would be 0 because we started with 0 and then we're depositing money. And here the future value is the one we have to compute. So if you like, you could always put things in here. This, of course, would be the payment. All right, that's equal to negative 200 at the end of each quarter. So the PY, as I told you before, would be equal to 4. You can account earning 2.9%. So that would be the IY is equal to 2.9. And interest is compounded quarterly. So here we would have CY is equal to 4. All right, how much will you have in the account in 15 years? So you would have to compute today. Here we are going to, we're going to compute the future value. All right, so those are the bits of information that we need. And with that, we can go ahead and put it into the calculator and do the question and get the answers. The first answer. All right, so let's do all of that and we will get the result. All right, so it's 15 years. So that is also important because that goes to help us to calculate the value of n. All right, so either way we could do it. We can work from here. We turn on the calculator. So second IY, that puts us for the PY value, which in this case is 4, enter. We go down, CY is also 4. We could either leave it or we could enter. And we quit, second CPT. Now it's 15 years, so as we would do, we put the 15 and we go second NN. So N turns out to be 60. If we wish, we could come in here and enter the value so we don't forget that that value is indeed 60. Okay, IY is 2.9, so we go 2.9 IY. 0 for PV. Remember, we did that on the question there. There is a 0 for PV. We could continue from right here, $200, and we make it negative for the payment. And then we go and we compute the future value. So we compute the future value, and it turns out to be 14966.63. Okay, we can go and put it in here. What could it be? 14966.63. Okay, of course, when you're entering the answer, you would not put in dollar signs and what have you else. Okay, so that would be the answer. All right, so let's go and let's check. Now we have how much will be the total amount of money deposited into the account after 15 years? So let's see, we can do that. How much will be deposited into the account after 15 years? So the amount deposited, so the total, we should put total amount deposited would be equal to what? Well, each payment times the number of payments, which in this case is the value of n. So that would be what? Well, 200 times how much? N was 60. Now, if we don't remember, because recall n, and the answer was indeed 60. And then we press equal. So we could go and we could multiply, and we could recall the payment. We could make it positive, press equal, and we get $12,000, right? So 12,000. That should be the answer for the total amount deposited. Okay, so over here we put in, it must be a positive value, so please do not make that error. And how much interest will you earn? All right, so how much will be the interest? Well, how do we get the interest? Well, we have to take the future value. Okay, so the interest earned equal to the future value minus the total amount deposited. So that would be equal to what? Well, what was the future value? The future value was 14,966.63. So 14,966.63 minus 12,000. So that would be equal to 2966.63. We could check that on the calculator. We could go recall the future value and then subtract the 12,000, and that turns out to be 2966.63. So there we are. Okay, so there we have it. And we are, hopefully, we are correct. All right. So 2966.63. And we submit, and we seem to be correct. Yes, we are. Okay, so that is quiz 4, question 3. All right, so let's go to the next question, question number 4. All right, that has also been copied, so we will go down and find question number 4. Deposit $228 at the end of every 3 months into an account that earns 4.36% compounded semi-annually. All right, so this amount here is the deposit. So that would be that's a payment. And that's equal to, let's put a negative 228. All right, at the end of every 3 months. End is important. You will see how that plays a role later because you could have deposits at the beginning. All right, so these are deposits. So these are payments. And so this would be 4, all right, into an account that earns 4.36%. So that is our IY is 4.36, and it's compounded semi-annually. So that means CY is equal to 2. All right, find the maturity value. That means the future value. So we have to find the future value, then we have to find interest earned. So maturity value, let's put it here, maturity value is equal to it's equal to the future value. All right, so we have to compute that. Okay, so we can go and highlight these values around here. That is one of them. Oops, sorry, I didn't quite finish the job there. We go here and we come down and we highlight that. We do the IY, and then we are using this 5 years and 6 months. Okay, and of course this CY also is important. So we will go and we will use these values. Of course, you could always go back here and enter them also. So PY turns out to be end of every 3 months. So PY is 4, okay? And CY is 2. N is, we will find that out. Let's wait and see. 4.36, or we could use the PY value. We have to use this value. So it's 4 times what? It would be something like 4 times, well, 5.5. Okay, now that would work out. I think that should be 22. But anyway, we'll check that with the calculator when we actually enter the values into the calculator. All right, present value is 0, of course. And the payments, that's negative 228. And then we will, this value here, we will compute. Okay, so compute FE. Okay, we'll have to take that out, of course, because the calculator wouldn't let us do that. Okay, so we go second, IY. PY is 4, or we can go back and still, if we like, we enter it. And then it's compounded semi-annually, so 2 for CY, and then we come out of there. Now 5 years and 6 months, okay. We go 6 months, we divide by 12, we change it to years, we add the 5, we click equal, which is 5.5, then we go second NN, and number 22 is indeed correct. Okay, the interest rate is this number up here, 4.36, so 4.36, and we click on IY. Okay, present value is 0. The payments is 228. We make it negative and we put it in there and we compute the future value, and that turns out to be, so we'll wipe this out of here and put in 5630.46. Okay, and hopefully we are correct. Now, the last thing we have to do is the interest earned. Okay, so let's go back to our Word document, and that is equal to, let's put a number in, 5630.46. And for good measure, we can highlight it in green because we got the answer. Interest earned, we take the future value. And then what do we have to do? Well, we have to subtract the total payments, which is payments, each payment times the value of n. Okay, so what is that? Well, the future value is 5630.46 minus 228 times the value of n was indeed 22, and we could check that right here by recalling n. Now we could go also and multiply by recalling the payment and equal. Now we have to make that positive, right? So this number here, we could actually do 5630.46 minus 5016. And that's equal to, now we could also go and say we just subtract the future value. Of course, we'll get a negative number. And if we change that into a positive number, the answer will be 614.46. And this would actually be the interest earned. Okay, so 616.46. Let's put that in here. Sorry, 614.46. That was a misspeak. Let's see how we did, and we did very well. So that is the correct answer, 614.46. Okay, great. We're doing well. Next question, number 5. Okay, this one is, I think it's a multi-part. How much will you have in the account after 5 years? That's the first part. And the second part, how much will you have in the account after 29 years? All right, now we are quite used to doing these questions now. Okay, you invest $170 at the end of every 6 months. So $170 is the payment, 170. End of every 6 months, what does that mean? It means that PY is equal to 2. Maybe we should go on and look at it on the over here. All right, then we can actually put in the values and get them properly sorted out. Okay, so you will understand what is actually happening. Minus 170, that would be the payment. Okay, so we can do our highlighting as we go along if we so wish. End of every 6 months, end of course comes up. Like I said, it could be end or beginning. End of every 6 months, what does that mean? Well, it means that it's twice per year. Okay, half of a year is 6 months, so twice per year is what is the correct number. Okay, for 5 years, this was a bit of a copy trouble there. So for 5 years, all right. So Into an account earning 6% compounded semi-annually. So CY, sorry, wrong, that is IY is equal to 6. Okay, so let's highlight that there. IY is equal to 6 and compounded semi-annually. So what does that mean for us? It means that CY is equal to 2. Okay, so we are doing very well. All right. After 5 years, leave the money without making additional deposits for, okay, without making additional deposits. So what does that mean? It means that the payment will be equal to 0 now. All right, for this part. Okay, so we have to be careful. It switches from $170 to 0. Maybe we should use a different color to get it. Let's see if this works. Oh, I guess we'll do it this way then. All right, so that seemed to work. All right, for 24 years. So this is also important, but this is the second part. So let's use the turquoise, and it's same 6%, so we don't have to worry. 6% compounded semi-annually, it's no change. All right, so no change occurs. All right. Okay, answer the following questions. How much will you have in the account after 5 years? After 5 years, we would have to compute we are computing the future value. Okay, so let's go. All right, where did we get to? Okay, let's start. All right, we can go back to here if we wish and do the compounded semi-annually. We have to fill these in anyway. So let's stop there. It's for 5 years. So, okay, so second IY, PY is equal to 2. Enter, CY is also equal to 2. Okay, we get out of there, and then we have the next one, the value of n. So it's 5 years, and then we go second and n. So n, the value for n is 10. Now the interest, we know it's 6%, so that goes in there. The present value is 0. All right, so 6% for the interest, 0 for the present value, and $170 for the payment. All right, and then we can compute the future value, which turns out to be $1,948.86. All right, so that is what happens. 5 years into the account, $170 twice per year. Okay, so that is the amount after 5 years. Now, the part you must realize is that this future value now must get entered into for the next part, and that gets into the present value. Okay, and we can make it negative. Okay, that is the part, that's the transition. Now there are no more payments, remember? It says that it says up here that without making additional deposits for another 24 years. All right, so no more deposits. After 5 years, the deposits have stopped. Okay, so now we're into compound interest in this scenario here. Okay, I should probably mark that down for you. And now, how much is the account after 29 years? Now, please be careful here. 29 years, but 5 years have already passed. So you will put in 24. Okay, 24 years, second NN. And this value would be 48. Okay, the interest rate remains the same, 6%. And then we will compute the future value. All right, so this is the set of numbers. Remember, I told you we have the future value but that we make it negative and we put it in as the present value. 0 for payment, and we compute the future value. And that turns out to be 8,053.18. All right, so let's see how we did. We submit this and it's all correct. All right, now if you wish to go back here, how much will be in the account after 5 years? That was the present value. I could recall that for us. And the answer would be, after 5 years, the present value would be, sorry, the future value. Okay, how much will the account after 5 years? So it's, you could put dollar signs, 1948.86. Okay, that's rounded to 2 decimal places. All right, okay. Now, how much will be in the account after 29 years? Remember the second part, I should put a note here, to calculate N, use 29 years minus 5 years, which would be equal to 24 years. Okay, remember, that is why we use that 24 when we did N. We went 24 and second and N. So N turns out to be, as it turned out to be there, that is the 48 right there. Okay, let's go back here. So that is the N. So you use N, but the actual value for N, oops, sorry, whatever happened there, something mysterious took place. The value for N is equal to 2 times 24, and that is where the 48 is coming from. All right, so that's the actual value for N. All right, great. Now, how much will be in the account? So the answer was, let's recall the future values. So this amount will be in the account, 8,053.18 will be in the account after 29 years. Okay, so that would be the answer. Maybe we can put it in green so that we know what our answers are. So that is it. That is question number 5. All right. We can go back here. We've completed question number 5. Everything works well. And then we can go to question number 6. All right, so next question is question number 6. All right, let's go to our Word document. He purchased a car by making a down payment. All right, so this is a down payment. We have to be careful now, all right, how this works. And weekly payments of $375 at the end of every week for 7 years. All right, so weekly payments, that would mean that what? PY is equal to what? 52 weeks in 1 year, correct? Yes, I would think so. PY is equal to 52. Okay, so there we are. Of $375, so PMT is equal to negative 375 at the end. Okay, it's the end also. End is important. Like I told you before, you'll see big N show up in a little while. 7 years. As we go on to the next quiz, we'll see big N. If interest was 1.95%, so that is IY is equal to 1.95 compounded weekly. What was the purchase price of the car? All right, so we have to calculate what? Well, we have to get at the future value or the present value. Well, let's see. The purchase price of the car, we have to get to the Yes, we have to get the present value. All right, why? Because the car is to be paid off. Okay. Okay. Let's put it this way. FV is equal to 0 because the car has to be paid completely. Okay, after 7 years. Okay, it has to be paid off. I guess we should say paid off completely after 7 years. Okay, so really we're after the present value. All right, so it might be better if we start to fill in some numbers in here. Okay, let's skip the N. We know the IY value is 1.95. We know that PY is making weekly payments, so that is 52. The compounding is weekly right here, okay? And we have weekly payments, okay? All right, present value would be what we want to compute. Okay, so let's put compute in there. It's for our reference, not for anybody's use. Okay, so it's $375, so 375, and the future value will be 0 because the car should be paid off. All right, let's remove this so we get rid of all that red there. Okay, so let's find the present value. All right, so we go second IY, weekly payments, so 52 would be the PY value, and the CY value is also 52. Okay, now how many years? Well, it's 7 years, all right? So we put in 7, we go second and N turns out to be 364. All right, so we're doing well. Okay, interest is 1.95, and that's the IY. The present value, we are going to compute that. The payments, we're making payments of $375. We make that negative, and that's every week. And we said that the car has to be paid off, so the future value must be 0. So we compute the present value, and it turns out to be $127,000 and 127. Okay, 127,571.36. All right, let's do that. Okay, so that is the present value. All right, so what is the purchase price of the car? Well, there was a down payment of $10,000. So that has to be added to this present value. Okay, so let us go to maybe the Word document, and we can do some more there. All right, so the present value, okay, we can use bold, that's fine, 127,571.36. All right, but if you want to get the purchase price, oops, purchase price of the car is equal to what? You have to take the present value, and we have to add the down payment. So that would be 127,571.36 plus $10,000, 000, and that would put us to a grand total of 137,571.36. Of course, we could just put it in there and let the calculator add for us $10,000 and 137,571.36. Okay, let's highlight that, copy it. It's easier to do it that way, and there are no mistakes about the answer. And I will put that into here, and we will see Oh, the cost of financing. Okay, that's the last part. Let's do that part and finish the question. What's the cost of financing? Well, the purchase price of the car. So the purchase price of the car, I did it up there, is 137,571.36. Okay, so let's pull this up a little bit. Okay, what's the cost of financing? Well, you finance the car, it was really the loan that was paid. So that would be what? Well, the present value was 127. This is the present value here. So how much cost of financing is really the total payments minus the present value. Okay, if cost of financing is for the loan, it is not the down payment. The down payment does not play a role in that at all. Okay, so the payments that were being made were what? $375, right? So 375 times the value for n, we could always recall n, and it turned out to be made 364 payments. And then we subtract today. How much was the present value? 127,571.36. This number right up here. Okay, so we can go and do that on the calculator. It will do it nicely for us. Recall the payments. Okay, we can make them positive. Multiply by 364 and then subtract 127,571.36, and that should be the answer. So the cost of financing was $8,928.64. Okay, so let's copy that and let's highlight it, and let's go back to our question and we enter it. Remember, enter a positive value. All right, let's hope that this is correct, and I hope it's working right. Yes, it is. And that brings us to the end of quiz number 4. Sorry, it was 6 questions, quiz number 4.